Guys, today we are going to do question number 1 of the February-March 2025 paper 4, which is extended chemistry. So it's paper 4-2-0620. So we're doing question number 1. So question number 1, it reads, using numbers only, state the percentage of oxygen in clean dry air. So this is a simple core question. We just need to know that the percentage of oxygen in clean dry air is 21%. So it is 21%. So you need to know that oxygen is 21%. The other gases such as nitrogen it is 78%. Carbon dioxide it is 0.03%. So these are other gases that are found in clean dry air. Then the typical operating temperature in degrees Celsius used in the Haber process. So in the Haber process, the typical operating temperature is 450 degrees Celsius, which is the optimum temperature required in the. So the optimum conditions using the Haber process, we need a temperature of 450 degrees Celsius, and we need a catalyst of iron and 200 atmospheres of pressure. So the number of atoms in a diatomic molecule. So the key term here is di. So di, it means 2. So scientifically di means 2. We also have the term mono, it means 1. Then we have tri, it means 3. Tetra, it means 4. So in a diatomic molecule, we have 2. Okay, so diatomic molecule, there are 2 atoms. Then part D, what is the maximum number of electrons in the second electron shell? So the maximum number of electrons in the first shell, it is 2. The second and the subsequent shells, the maximum number of electrons is 8. So the maximum number of electrons in the second electron shell of an atom is 8. So this is the maximum number of electrons. Then what is the number of hydrogen atoms in an alkane with 7 carbon atoms? So in alkane with 7 carbon atoms, we are going to use the general formula for alkanes, which is CN H2N plus 2. So this is the general formula for calculating or for finding the molecular formula of an alkane. So since we have been told that it has 7 carbon atoms, we are going to substitute. So we substitute here, N is the number of carbon atoms. So since here is 7, I'm going to say C7 H2 multiplied by 7 plus 2. So this becomes C7, 2 times 7, that is 14 plus 2. That is 16. So the number of hydrogen atoms that we have is 16. Then the last part of our question is part F, which says the number of particles in 1 mole in standard form. So all molecules or all particles, they have 6.02 times 10 to the power 23. So this is known as Avogadro's number. So it just says that every substance, or every 1 mole of any substance, it consists of 6.02 times 10 to the power 23 particles. The particles can be atoms, they can be molecules, they can be ions, or they can be electrons. So that's that, guys. Let's meet the next time.